Okay, these notes are predicting the products, and these are for synthesis, decomposition, and combustion reactions. Okay, we're going to start with synthesis reactions. Now, there are quite a few different synthesis reactions. I mean, you put any time you have more than one reactant and you have one product, that's called a synthesis reaction. I am not going to have you worry about anything that has 3 or 4 different reactants and then trying to have you figure out what the product is. Instead, we're going to deal with just 2 reactants and making a product. Now, I'm going to be giving you 4 different rules or 4 different things to look for to predict the products. There are more than this, but these are the only 4 you're going to have to deal with or have to remember. The first one is when we have a metal plus a nonmetal. Whenever you take a metal and add a nonmetal to it, react a nonmetal with it, it is a salt, a binary salt. Now, the most everybody knows is NaCl. So let's start out with that one. So, whoops, I guess it would help if I had the pen on. So we have sodium, and then we're going to react it with chlorine. Now remember, chlorine's a Hofbrinkel, so we have to have 2 of those. It becomes NaCl, table salt. If we had Mg, well, I'll do the next one. I'll do another example in a second. Now, this reaction is not balanced, so we have to balance it. There we go. And you could also do another one. You could do Mg. Take magnesium and react it with, let's say, bromine. Okay? Now, one of the things that I didn't stress is when you put together the binary salt, you do have to worry about the charges. So Na has a +1, Cl has a -1, so that's how we got NaCl. Here, magnesium has a +2, and bromine has a -1. So we're going to have to crisscross down. So this is going to be MgBr2. Oh, look, it's balanced. But magnesium bromide is also called a binary salt. Okay? So just because you hear the word salt, don't think it's automatically sodium chloride, table salt. Okay? Anytime you put together a metal and a nonmetal, it's a salt. Okay, so let's look at the next one. So that's the first one. So we'll put a number 1 here. Second one, you have a metal oxide plus water equals a metal hydroxide. So a metal oxide, that means it's a metal with oxygen attached to it. Excuse me. So let's do a simple one. Let's do sodium oxide. So sodium oxide is Na2O. So I know it's an oxide because it has an O at the end and it starts with a metal. And then we're going to do water. Now, to predict this product, it's a metal hydroxide. Well, I know hydroxide is OH minus. Okay, hydroxide's a polyatomic ion. So what's going to happen is that metal, that sodium, is going to combine with the water, and it's all going to rearrange, and you're going to have the metal plus hydroxide. So you're going to have NaOH. Okay, so the metal and then OH. So if this was MgO, if this was magnesium oxide, we would have magnesium hydroxide. If this was calcium oxide, we would have calcium hydroxide. So whatever metal we started with, excuse me, whatever metal we started with, that's the hydroxide. Now we just have to balance it. So there's 2 sodiums on the left-hand side, so we're going to balance it with 2 sodiums on the right-hand side. Okay, so now let's check our O's. We have 2 O's on the left, 2 O's on the right, 2 H's on the left, 2 H's on the right. That's correct. Now the reason why I know sodium hydroxide is NaOH is because Na has the +1 and OH has the minus. So you still have to be able to make these formulas. I can't stress enough. You have to make these formulas. Okay, now the next one. We have a metal chloride. Okay, that means it's a metal plus Cl. So we'll look at magnesium chloride. That way, actually, no, let's go with sodium chloride. It's the easiest. So sodium chloride plus oxygen. Remember, oxygen's O2. Now, if we have to do this in words, that's when you're going to have to remember the Hofbrinkel. But whenever you see the word oxygen, always think O2. Now your product is going to be a metal chlorate. So you need to look at your polyatomic ion list. And chlorate is ClO3 with a minus charge. So our metal happens to be sodium, which is a plus. Okay, so this is Na has a +1 charge. Chlorate has a -1 charge. So it's pretty easy. Our answer, or our product, is going to be NaClO3. Now, we do have to balance this. So since we have 3 O's on the right and 2 on the left, remember you have to do this, the 3-2 situation. Put the 2 in front of here, and we should have it. That should be balanced. Okay? So, I mean, so far it should be pretty easy. I'm giving you what the product is going to be. Okay? So, on a quiz or a test or something, I would give you the names of the reactants. Okay? So I would say sodium chloride reacts with oxygen. Well, you should recognize sodium chloride as a metal chloride. Reacts with oxygen, then, oh yeah, that's a metal chlorate. That means that's going to be sodium chlorate. Okay? So I'm trying to keep it pretty simple. There are some other more complicated ones, but I didn't feel the need to give them to you, so I found the 4 simplest for the synthesis reactions. And it's, in the words. It's right there. So let's go on to the next one. Sorry. I'm losing my voice here. So that was 3. So the 4th one is a metal oxide. So once again, we're going to do Na2O. This time we're going to react it with CO2, carbon dioxide. Now it says the answer should be a metal carbonate. Well, carbonate is CO3 with a -2 charge. It is also a polyatomic ion. Now my metal here is sodium with a +1 charge. So when I put the 2 products together, with sodium having a +1 and carbonate having a -2, oops, it's a CO3, this is going to go here. So I'm going to get Na2CO3. Okay, so that's sodium carbonate. So now we just have to make sure it's balanced. I got 2 Na's on the left, 2 Na's on the right, 1 C on the left, 1 C on the right, 3 O's on the left, and 3 O's on the right. So I'm balanced. Okay, so that's it for synthesis. That's all there is to it. Okay, so you just kind of have to know the 4 rules. I won't be giving them to you at any point in time. We will have a quiz on this either Monday, well, not Tuesday, so it'll have to be on Monday. So I will give you a couple of them, either synthesis, I might give you like 1 synthesis, 1 decomposition, 1 combustion. But either way, you will have a quiz on Monday on this. Okay, a quick little quiz. I just want to make sure you guys are getting it. Okay? Okay, decomposition reactions. Well, I think they're the easiest because once you know synthesis, you know decomposition. It is, oops, it's just the reverse of synthesis. So instead of putting things together, we're taking them apart. But I'm going to keep the same 4 rules, just I'm going to write them backwards. So like for rule number 1, if you have a binary salt and you take it apart, you're going to get the metal and the nonmetal. So if we look at Na, sodium chloride, okay, when we take it apart, we get sodium and chlorine. There you go. Pretty easy. If we wanted to do, let's do the MgBr we had over there. MgBr2. Taking that apart, we end up with Mg plus Br2. Nothing difficult about that. So you're just going to take the 2 pieces and split them up. But you do have to remember Hofbrinkel, okay? So otherwise, you'll get it wrong. Okay, so the next one. Metal hydroxide equals a metal oxide in water. So no matter what metal hydroxide I give you, you should be able to take it apart. So let's do magnesium hydroxide. So if we take that apart, we get the metal oxide. Well, the metal is Mg, which by the way has a +2 charge. Okay. Our oxygen has a -2 charge. So since they both have the same charge, it's MgO. That's when they form together, plus water. Now we just have to balance it. So we have 1 Mg, 1 Mg. 2 O's, oh, we have 2 O's on the right. 2 H's on the left, 2 H's on the right. So we are balanced. So it doesn't matter what metal hydroxide I have, it's always going to be metal, the metal oxide, and water as your two products. Okay, let's look at the third one. So we're going to take a metal chlorate. Now remember, chlorate is ClO4, O3, I can't write today, with a minus charge. So let's look at lead 2 chlorate. So PbClO3 with the 2. Now this 2 right here tells you what the lead is, what the charge on lead is. Sometimes you can look on the periodic table, but lead is one that you cannot. So you've got to keep that in mind when you make your product. Now there's a little hint here. Chlorine has a -1 charge. So does chlorate. So what you can do is replace the ClO3 with Cl and then drop the parentheses. So watch. So we're going to take the metal chloride. So I'm going to write it like this, only I'm going to leave a blank spot. I'm going to put our Cl in there. And then, of course, I'm going to erase the parentheses. But because the ClO3 and the Cl have exactly the same charge, there's going to be the same number of them in the product. Okay, so the metal chloride is PbCl2. And in fact, let me go ahead and write this as PbCl2. So it's a little easier to write. Plus oxygen. Now we've got to balance it. 1 lead on the left, 1 lead on the right. 2 Cl's on the left, 2 Cl's on the right. We have 6 oxygens on the left, so all I gotta do is put a 3 there, and I have 6 oxygens on the right. Okay? Not that difficult. So the same is gonna go with metal carbonate. Okay? Your metal carbonate is gonna be metal oxide plus CO2. Now, carbonate has a CO3 with a -2 charge, and oxide is a -2 charge. So we're going to do the same thing. So however many metals we have or carbonates we have, we're going to have that same number of metals or oxygens or both on the right. So for example, let's look at iron. Oops. Probably would help if I put the right iron. Okay, it's going to be iron 3 carbonate. Remember we crossed, so it's iron 3. So there's 3 of those carbonates and there's 2 of the irons. So when we make the product, this is still going to be iron 3. So you're going to have the same number of the Fe's and you're going to have the same number of oxides as you have carbonates. So you're going to have 3 of them. We had 3 carbonates, we're going to have 3 oxygens plus CO2. Now we just have to balance it. So we have 2 Fe's, 2 Fe's. That's fine. Now I have 3 C's. So I'm going to go ahead and put a 3 here. Okay, 3 C's on the right. On the left-hand side, I have 9 oxygens. On the right-hand side, I have 3. Here, we have 3 plus 6, which is 9. So I'm now balanced. Okay? So it's not that difficult. You just got to pay attention to certain things. But that's it for decomposition. Now let's go on to combustion. Okay, combustion reactions. They're a little different than synthesis and decomp. Oxygen combines with all of the elements of the reactant in a combustion reaction. Basically, you're burning it and you're taking the oxygen takes it apart and reacts with each element. When the reactant is a hydrocarbon, that means it has C's and H's only, well, C's, H's, or C's, H's, and O's. The products are always CO2 and H2O. So we want to add in here too, CX, HX, and OX. That's considered a hydrocarbon still, even though it has the oxygen in it. And your products are always going to be CO2 and H2O. Okay, so let's try an example. Let's try one where look at the demonstration. Remember the demonstration we did. We took magnesium ribbon and I burned it. So remember I told you it was a synthesis, but it was also a combustion. So if I hadn't put the equation up on the board, let's see if, basically you could have figured it out. So Mg plus O2. Now oxygen combines with the reactants. In this case there's only one, it's magnesium. So it combines with the oxygen, so MgO. How do I know what the product is as far as the formula? Well, Mg has a +2 charge, O has a -2 charge, and they cancel each other out. Now I do need to balance it, so there we go, with two of them. Now, what if, let's say we took sodium, okay? So I took a piece of sodium and I burned it, which you can do. It's not that, well, it's quite dangerous. I would rather you didn't, but you can. Okay, so now we're going to have to put together the sodium and the oxygen. Well, once again, I know sodium has a +1 charge and oxygen has a -2. So when it combines, it's going to be Na2O. Okay, and then we're going to have to balance it. So we have 2 oxygens, 2 and 4. Okay, so I'm not going to give you one with 2 products because the only problem with when you react a metal, basically a binary compound, which contains a metal and a non-metal, you get the metal oxide, but you also get, I don't know how to describe it. It's a covalent compound. So if I had taken FeS, I'll show you. You don't have to know this one, by the way. So if I had done this one, not only would I get FeO, but I would have had to know that I get SO3, not SO2 and not SO, okay? I'm not going to make you guys remember what each one does, okay? There's a couple specific rules. If you're in AP chemistry, you might have to know them. Here in honors, no. So I will only give you one element, oxides, well, combustions, or hydrocarbons. So let's do that one next. So we're going to take methane, which is, this is what goes on in your furnace. Your furnace burns methane. Now if it burns completely like it's supposed to, it should only have CO2 and steam, water vapor, as your 2 products. You should not have CO. But I guarantee you, you get a tiny bit of CO. When the furnaces don't work very well, you'll get a lot of CO, and that's why you should have a CO monitor near your furnace. Okay, but let's balance this. I kind of digress here. So let's balance this. Okay, so that's my hydrocarbon. Now remember, I also told you that a hydrocarbon can also have an oxygen in it and still be considered a hydrocarbon. So if we do C2H6O plus O2, you're still going to get CO2 plus water. Once again, you just have to balance it. So 2, 3, and 3. So there it is balanced. But this is considered a hydrocarbon, even though it has hydrocarbon and oxygen. So it's really technically called an oxyhydrocarbon, but it's still a hydrocarbon, okay? So you're going to get CO2 and H2O. Okay, now when the reactant is a hydrocarbon with a nitrogen, then the products are CO2, H2O, and NO2. Now the first one I'm going to give you an example of, it was hard, well, actually maybe I would make you balance it. In this example, I'm not going to make you balance it, but it's hydrogen cyanide. And we're going to burn hydrogen cyanide. Oops, I'm going to go ahead and put the numbers in front. That's a 9, by the way, 902. You're going to get CO2 plus H2O plus NO2. Those are always the products when there's a nitrogen. So when you have a hydrocarbon with a nitrogen, so here's my hydrocarbon, and then here's my nitrogen, you're going to get CO2, H2O, and NO2. So here's a better example, actually. So let's take this. It's C3H6NO. Now this is a oxyhydrocarbon with a nitrogen, okay? There's a specific name for it, but I'm not going to have you worry about it. So we're going to burn that. So once again, my products are going to be CO2 plus H2O plus NO2. Now to balance it, well, let's see if we can balance it together. We have 3 C's, 3 C's, 6 H's, 6 H's, 1 N, 1 N. Now I'm going to add up all my oxygens on the right-hand side. I got 6 here, 3 here, and 2 there. So I have 11. Now I already have 1. 1 plus 2 times something gives me 11. So if you were to do this algebraically, 1 plus 2x, 1, equals 11. Well, 2x equals 10, so x equals 5. So we're going to put the 5 there. So that's kind of how you do this one. Okay? Not that difficult. Hopefully you can handle it. You'll be doing 6, 8, and 6, well, 6, 8 to 610 will be the practice problems, and they will be up tomorrow at some point. I'm just not sure exactly when. Okay? So hopefully you understand it. We'll do a warm-up and do some more practice problems with this. So I will see you tomorrow. Bye.